Hello, and welcome to Module 2.1, Writing and Interpreting Equations. Our objective for today is that I can translate sentences into equations, and I can translate equations into sentences. Now, what is an equation? It is a mathematical statement that contains two expressions and an equal sign. So unlike Module 1, where we just had expressions on their own, we had something like 3x plus 4. Now we're going to include an equal sign, and we are going to say that that expression is equal to, I don't know, like 2x, right? So those are just an example, but it is going to be two expressions. So those could be any number of terms. They could be constants, there could be variables, it could be anything, and they are going to be set equal to each other. Now, a constraint is a condition that a solution must satisfy. So, for example, we could say that the solution, the length must be greater than 0 because we cannot have a negative length of an object, right? You could say your time has to be positive because we don't measure time in a negative way, right? So those are limitations, and the solutions to an equation must satisfy it. The cost of an object can't be negative, right? We're not going to get paid to buy an object. No, if you did that, something is wrong in your calculation. So let's take a look at some examples, and we're going to write equations based on the sentence we are given. So the first one here is 20 minus the quotient of 7 and x is the same as twice x. So let's do this piece by piece. So we have 20 minus, so that's going to be just exactly how it sounds, 20 minus. Our next piece is the quotient of 7 and x. So we know it's 7 over x, because when we say the quotient, we know we're doing division, and the first thing listed is our numerator, the second thing listed is going to be our denominator. Next we have is the same as, equals. And lastly, twice x is 2x. So as we look at this piece here, we've got is the same as. That is telling us kind of in a whole bunch of words that we are going to be equal to. So let's look at letter B. 10 less than 4 times a number is equal to 16. So that first part, 10 less than, so that is going to be minus 10, right? 10 less than we're taking away. Some of us were making that mistake in Module 1, and we need to pay attention to that. If we say something is less than, that is what we are subtracting from whatever we're referencing, okay? So 10 is 10 less than 20, right? So 10 less than minus 10, okay? We've got 4 times a number, so we've got 4 times a number, 4x, is equal to, hey, look, there's that word is again. But this time we specified equal to, and we have 16. So our equation for this would be 4x minus 10 is equal to 16. Now, given that there's no specific variable used here, if you used any other variable other than x, that still would be acceptable because we didn't specify what our variable is going to be. All right, letter C, we have 5 times the sum of x and 12 is 3 times x. So 5 times the sum. 5 times the sum, all right, of x and 12. So we have x plus 12 is, so we've shortened this. We went from is the same as, is equal to, and now we just have the word is. And in math, when we are writing an equation, the word is, it's going to be a trigger word for us. It is a clue. It is our flashing red sign that here is where my equal sign goes, right? The word is it bridges the two pieces of your equation as it's being said verbally. So that is telling us where our equal sign is going to be. And lastly, we have 3 times x is just going to be 3x. Now we have 3 you-try problems for you to go through right now. Do those and then come back and check your work against mine. All right, so First thing we have is 15 plus. So we can do 15 plus the product of 5 and x. The product of 5 and x tells us we're multiplying, is equals the quotient of 9 and x. So we have division 9 over x. Our next example, we have 20 divided by x, 20 over x, is equal to 5 plus x. Okay. Now, if you wrote it x plus 5, we know associative property from Module 1, that would still be the same. Same in the question above, if we had done 5x plus 15, still associative property, the order doesn't matter when we're adding, so you could do that as well. As we get later in the year and we start writing more formal equations, we are going to be talking about the standard form, which is the variable term comes first and your constant term comes second. But for right now, since we're just translating, we're going to do it just kind of in the order that the words come up in the sentence. All right, letter F. We have 8 times the quantity. So we have 8 times the quantity. 6 divided by x. 6 divided by x is equals x minus 1. X minus 1. And as we went, you saw I was color coding this so that we were seeing exactly where each of these parts is coming from in the words. Right. So let's write an equation. So example A, of 799 teens surveyed about what they do online, some use a social network and some do not. Of those on a social network, 430 say people their age are mostly kind online, and the remaining 193 do not. Write an equation to find the number of teens surveyed who are not on a social network. So the first thing we need to do is define a variable because we aren't given any kind of variable here, so we need to define it for ourselves. And we want to know teens surveyed who are not on a social network. That is what the question is asking us to find. How many teens were not on a social network? So I'm going to define my variable. I'm going to say x is teens not on social media. All right. So now I look back at my equation and I look back at the information I'm given. So we're told that 799 teens were surveyed. Well, that seems to be our total. That's the big amount, right? We're talking about all these factions within this survey, but in the end, we know that 799 teens were surveyed. So we have equals 799. Whatever we're doing, however we're approaching this problem, we know that at the end, there needs to be 799 pieces of data collected. So let's look at, of those on a social network, we've got 430 say people are mostly kind, and we have 193 that are saying that they don't. So 430 plus 193, that gives us what? 527. 627. So that gives us 623. So that's showing us just kind of how many people that are on social media, and we need to figure out, well, those involved with the ones that are not. We're really talking about a total here. So what I'm going to look at is an equation we are adding 3 pieces together. So we're going to start with 430, and we're going to add in the 193 that say that social media people are not very kind. And we're going to go with our final piece, which is x, that we are unknown about. And so from this, we could do 799 minus 430 minus 193, and we would find how many of the sample said that people on a social network are, or sorry, how you could find how many people are not on a social network. All right, let's take a look at letter B. I want you guys to try this one on your own, and then you're going to come back and check your work with me. Etu has read 12 of the 38 or 32 chapters in his assigned book. He plans to finish the book by reading C chapters each day for 8 days until the book is due. Write an equation that represents this situation. Now, let's go with what are we starting with? We know that he has read 12 chapters so far, right? We know he's read 12 chapters. How much is he planning to read? Well, he's going to read C chapters each day for 8 days. So we have 8 days times C chapters per day, and we know that we have our equal sign, and we know there's a total of 32 chapters in the book. So the amount that he's going to read is going to add up to 32. The pages he's already read, plus all of the chapters that he is going to read over the next 8 days. All right, let's look at example 3. Write an equation with multiple variables. The perimeter of a rectangle is twice the sum of the length and the width. So we're going to need to label a whole bunch of variables here. So the perimeter we're going to say is P, okay? So the perimeter of a rectangle is P is equals, we're going to have twice the sum of the length, L, and I use a script L because that's the way you see it in formulas, and the width, W. So there's our formula for the perimeter of a rectangle. Perimeter is equal to 2 times the parentheses, the length plus the width. Sometimes if you've seen it as 2L plus 2W. All that is that we use the distributive property. All right, you try letter B. Come back and check it with me in a moment. So the horsepower of a motor is the product of the motor speed and the torque divided by 5,252. So the horsepower, we're going to call that H. So H is equal to, right, because it's is the product of the motor speed. So we have speed times the torque. We're going to use letter T for torque, divided by 5252 over 5252. All right. Did you need to show the dot in between S and T here? No, because if we just wrote S and T next to each other, it would imply that we are multiplying. I did it just to make it abundantly clear. So let's look at examples 4 and 5, writing a sentence for an equation. In letter A, we have 2x minus 1 equals 5. So we could write that as 1 less than the product of 2 and x is 5. All right. Letter B, again, kind of mimics the first one. We have 15 less than, we could say 6 times a number, just to switch it up a little bit, is 45. And number 3, we've got parentheses involved, so we could say 3 times the sum of y and 1 is 12. All right. Now we've got 3 problems for you to try on your own. Do them and then come back and check your answer against mine. So letter D, we want to talk about and we want to make sure that we are doing the addition on the inside of the parentheses. So we need to make sure that's communicated and that we have an exponent. So what I would say is the sum of y and 3 squared is 25. Letter E, we have 7 times the quantity. We could write it a little different, so just so you see it written different ways. 7 times the quantity, P plus 23, is 102. So could I have written 7 times the sum of P and 3? Sure. But just writing 7 times the quantity, that's just a mathematical way of saying, remember there's some parentheses going on here that you need to pay attention to. All right. Letter F is back to just being basic, so we're going to go super basic with this one. 4 times x plus 5 is 17. Again, you have a lot of different options in the way you write these. There is some flexibility within it. Just make sure that all of your operations are being clearly identified and worked through. All right. Those are your notes for today. If you have any questions, please feel free to reach out during class tomorrow. Have a great day.